Okay, this is section 3.9, and this is number 45, and this is logarithmic differentiation. And we know that we can kind of simplify powers and products by using logarithms. That's probably, historically, that's one way they were used a lot to simplify calculations, by reducing powers to products and products to sums. So this is a situation where this is going to be an advantageous way to take this derivative. So my function was y equals the fifth root of x minus 3 to the fourth times x squared plus 1 all over 2x plus 5 to the third power. So first of all, we change this to exponential form, so it's the same thing except the fifth root is 1/5 power. And then we take the natural log of both sides. So I take the natural log of this left side, which is the natural log of y, and the natural log of this side. And then we know that if we've got logarithms, if we've got an exponent, we can put that in front, so we just move that 1/5 in front. Now we know the log of a quotient is the difference of the logs. The log of a quotient is the difference of the logs, plural. So I broke that up. The log of the top minus the log of the bottom. One of our major three properties of logarithms. I also know that the logarithm of a product is the sum of the logs. So again, I can break this up, the 1/5 staying out front, the log of x minus 3 to the fourth plus the log of x squared plus 1, and then I still have minus the log of 2x plus 5 to the third. That was in the bottom. And then again, we know we can put the exponents in front, so move the exponents in front. So we put 4 in front, no exponent here, and we put 3 in front. So that was our third property. We had three properties of logarithms. The log of a sum is the sum of the logs. The log of a product is the sum of the logs. The log of a quotient is the difference of the logs. And the log of something to a power is the power times the log of that something. Those are our three major properties of logarithms. Okay? So now we've got this all separated out, and now I can multiply everything by the 5 so I won't have to be moving it on the other side. So that's got 4/5 the log of the natural log of x minus 3 plus 1/5 the natural log of x squared plus 1 minus 3/5 the natural log of 2x plus 5. And now I'm ready to take the derivative. So the derivative of the log of y is, or remember the derivative of the natural log of x is 1 over x. Or for u, it's 1 over u du dx. So that's what we have, basically 1 over y dy dx. Because this is y with respect to x. Then if I take the derivative of this is going to be 4/5. This is a constant. And the derivative of x minus 3 is 1 over x minus 3. Times the derivative of x minus 3, which is 1, so I don't need to worry about that. Then I've got 1/5 here, comes down, and then this is going to be 1 over u du dx, and this is going to be my u. 1 over x squared plus 1 times the derivative of this will be an inside function, that's going to be 2x. Derivative of 1 is 0, the derivative of x squared is 2x. And then again, this is going to be 1 over, this is my u du, and my du would be the derivative of that, which is 2. So 3/5 times 1 over 2x plus 5 times 2. Now I can multiply both sides by y to put this y up on top. So I have this y over here, and then we just put 4 on the top and 5 times x minus 3. And then I've got a 2x, so I can put the 2x on the top and 5 on the bottom. So 2x over 5 times x squared plus 1. And 3 times 2 is 6, so that can go on the top, minus 5 times 2x plus 5. So now we have a nice answer, except we want our answer in terms of x, not in terms of y. But we know way back up here, what was y? Way back up here, y was equal to this. So I just substitute this in for y at the end. So instead of writing y, remember way up at the top, y was equal to this. So I write this for y, and then I have these. And I'm done. Okay, so that was a bit of work. And that's logarithmic differentiation.